Okay, let's talk about assignment three and some tips to help you go. Now, again, this is the assignment where we're getting doing some math problems for kids. So, the main thing is this assignment isn't asking you to do anything you haven't done before. It's just really a combination of all the things that you've learned so far. Maybe in some ways this is a culmination of a bunch of thoughts in these various programs put together in one program. So, first of all, let's talk about the IPO model and how to use that in this one. Um, and so I called this simple tips because, again, we're not doing anything new. So, what is it that we want to input? Well, we're going to ask the kids to give us two numbers, right? So that's number one. What is it that we have to process? Come on. And the information there is like there's basically four math problems that we need to process, and then what is it that we want to output? And first of all, it did mention a friendly tone, and it wanted to do like show the work in some ways to put in like 2 plus 2 equals 4, and not just the answer. So that's what we're trying to do. The other thing I like to have people ask is what kind of data am I looking for in the input? And that's maybe one of the only interesting things about this problem, as far as maybe being tricky, is do you expect the kids to enter only integers? I mean, like probably kids would expect integers, um, or would you allow them to enter in decimals? And that one, let's start with that one. Although I'm gonna separate everything out. I haven't done this too much yet in my samples that I've been giving, but it's often a good idea to separate these things out and purposefully put them into the different categories. So let's just say that we have a number. Oops. This is going to be my completely non-kid friendly way to enter these two numbers. Well, first of all, wow, I'm getting forgetful. Sorry. I'm forgetful and I can't type any longer. And so we have two inputs. And so maybe you ask yourself, okay, I'm going to get these to become integers. So I'm going to cast them as integers. And then I know that I can do all my math that I have to do, right? Because then down here we're going to have some math, and we want to do like num1 plus num2. And then out here we want to output, and so we're going to go print, and I'm not going to, well, I am going to give you a hint on this in just a minute, but for right now, let's just print the answer. Um, so then you go and run it. So again, the tip I'm giving right now is about this question, is how do you want to do your input? And you're thinking these kids, they're just going to put 2 plus 2 equals 4, and some kid comes and enters 5.6. And the reason that's a problem is that you literally, see, invalid literal, you said this is going to be an integer. And then some kid comes in and types in something that's not an integer and kind of breaks it. Now, it's too complicated to get into what we might call error checking and forcing them to put in the right answer. So if they get an error, they get an error, they kind of break our program. I mean, even when we do fix this, there's still nothing we can do for right now. If they want to say, I want elephant to be one of my numbers, that's just, going to be a problem. So you could ask yourself, am I going to force it? And again, we're not going to show this to anybody. So if you just want to run it and say, no, they did put 2 and 3, and then it's 5, you can do that. The only thing you want to think about then is you would say, well, maybe I'm going to force this to be a float. That doesn't help if they put that the answer is elephant. There's nothing we can do about that right now. But now they could put something like that and get an answer, right? Now, this is a problem with floats that then that's actually one of the issues about floats. That is interesting. That computers get their math wrong sometimes when they're trying to estimate things. That's fun. But and so you might say to yourself, well, I don't want that to happen, and so I'd rather stick to integers because I don't want to confuse people with strange answers. So that might be why you stick to integers. So there's just one thing to think about. Okay. Now the second thing to think about is when we do our output. And this one is the one. This one's going to challenge you, to really have good output because you have to have some real going back and forth between these two things. So addition answer, maybe I put a colon there after that. And no, I don't need a space. And then I have to put in num1, and then I have to put a comma and put in the quote for the plus sign, and then I have to put in the comma and put in number 2, and then I have to put a comma and I have to put a quote for the equal sign, and then I can finally put my answer. So the only thing about this one, it's kind of challenging you to think about, this data type issue, and it's challenging you to see if you are good at putting in the numbers so that you can get really good results. Because now this output is kid-friendly output because they can see the results. Speaking of kid-friendly, there is one other thing, which is, I just got done lecturing, I feel like, in the other two, saying always keep it in input, process, output, like you want to keep these things separate. But really, in the input stage, if you think about this, this is when the people are first seeing the program, and you might actually want to put some print statements up here, which you can argue, of course, are output. Welcome to the math lab. And, and so you're going to put some output here. Now, when we talk about the output process, we're really saying, the results of the math are getting output. So this still is the output process, but sometimes in your input, you want to create a particular tone or particular information that you give people at the beginning. So yes, it's not just using input statements. It could be doing some other things as well. And I'm trying to think if there's anything else I wanted to lecture on in this one. I'm just going to take a quick minute to say that Python 2, when you do division, if you used integers, it does weird things. And so it's just, as an aside, they improved the division in Python 3, and it's something that you don't have to worry about. So that's nice. In Python 2, I had to have a whole nother tip to explain what was going on with division, but that's been fixed, and division makes a little bit more sense now. So you could just say, whatever, Mr. Steen, we're just going to do what we normally do and not worry about those behind-the-scene details. But I find that interesting. If you want to know more about that, you can ask me, and I'll show you what we had to used to do for Python 2. Okay, good luck and have fun.